Hello everyone. Today I wanted to talk a little bit about Kubernetes Ingress, what is an Ingress controller, how to deploy it, and the reason I'm making this video is because I popped a blood vessel trying to figure this thing out and I wanted to document it so I don't forget about it. So let's start. This is going to be more of a demonstration oriented video rather than rambly one. I mean, I would still end up rambling pretty much, but uh, we'll see where the rubber meets the road. Okay, we'll have a nice deployment going on here. First things first, we need a Kubernetes cluster. I would recommend using a cloud native Kubernetes distribution. I'm using DigitalOcean's Kubernetes service. You can use Linode, GCP, what have you. The reason for that would become clear, like, I mean, spoiler alert. The reason for that is because we need a load balancer, and usually these distribution providers have a load balancer. The load balancer is needed for your ingress controller, and yeah, without that, you're kind of you are stuck in a bad way, right? You need that, so you can't just like you can't self bootstrap a kubeadm cluster and be like, okay, I'm going to have an ingress here. You're going to have a bit of a trouble if you do that. You can do it, but it's outside the scope of this video. So I have a two-node cluster called my cluster, surprise, surprise, on DigitalOcean, and I have actually connected my uh, kubectl client on my Linux environment here. So if I do kubectl get nodes, I will have all the nodes listed, and I do not have anything running in here. I have a sample application called app2, which is just a simple Node.js app. I'll just run it and show you what it does. Test port 8080. So now if I do curl um, localhost slash endpoint 1. So this is a simple Express app which listens on the URI localhost slash endpoint 1 on port 80 and responds with hello world. Any other path that you give it, it will respond by an error message. So you can see that Express is giving this HTML document as a return instead of our successful hello world one. And the reason I wrote this app is because it acts as a perfect demonstration for what an ingress is supposed to do. Okay, so that's that. Let's deploy this image first to our Kubernetes cluster. To do that, we'll just run kubectl create deployment. I mean, you can create a replica set just as easily, but I'll just call it deployment. My deployment. The image would be app2 and replicas. Because I have two nodes, I can keep like two replicas, no problem. And yeah, deployment created. Let's check in on it. Get pods. So my cluster is pulling in the images and it'll spin up the container shortly. Let's see. It's taking a bit longer than usual. Hmm. Why is this so slow? I'll probably have to edit this part out. Come on. Yep, there we go. So yeah, we have the deployment, but now the question is how do we access it? How can I hit that URL so as to get some service out of it, right? Because ultimately, like wherever your app is hosted, you would want users to use it, right? You would want to point a DNS to your app or website, and you want, like www.yourwebsite.com run on it, right? And with the high availability and all the other advantages of Kubernetes under the hood, right? And the question is, how do you do that? So in comes services. I would assume like if you're looking up on Kubernetes Ingress, you already know what services are. So services are basically the way you expose an application like a deployment within the cluster and without the cluster as well. So for this one, for example, if I do kubectl expose deployment, uh, my deployment, and I specify the port because it's listening on port 80, I'll just do like port 80. Uh, it should actually expose the deployment, right? And now if I were to kubectl get nodes, now if I were to like log into any of these nodes and do like a curl localhost port 80, I'll get the hello world response just like we did on our local Docker instance. You can also do this, by the way, of like logging into any of the pods. So if I create like a temporary pod, a busybox shell or whatever, and log myself into it, I can curl and like, I would be able to access this deployment as a service, right? So if I do kubectl get service, you'll see that my deployment is now exposed as a service here. Um, let's see if we can rename it to something better. Um, delete service my deployment. This doesn't delete the deployment, it just deletes the service. Uh, let's see if we can name the service something else because I don't want repeated names there. I'll call it my service. Ah, we can do that. There we go. So now if I do kubectl get service, the service is now exposed. You can see that there is a cluster IP for it. So if you log into any of the pods and then do like curl this IP address, you'll be able to access it. However, as you can see by the IP address itself, it's an internal IP. So the service as an HTTP endpoint is exposed within the cluster. Now, how do we expose it outside the cluster? Well, there are several ways to do it. If you follow along the documentation, one of the ways to do it is just like how you do it in Docker, which is like do a node port forwarding. And what that would do is bind all your cluster nodes, right, where the pods are running. So for example, for my service, there are, let's say, two pods, right, running on two of the nodes. So what node port would do is bind one of the port numbers on your node or your node's public IP to the pod that is providing you the service, my service in this case. And it's messy, but it works, right? But the problem you have with that is you don't have the flexibility of having like a proper DNS. Like again, like where would you point it? Like the whole idea behind Kubernetes is nodes are like nodes can go up and down, right? So you are creating a point of failure if you point a single a domain name to a single IP address of a single node, right? It becomes kind of a special case scenario in that case, and it's not very clean. So that is one way to do it, which again, like we would not do it that way. Another way to do it is through Ingress, right? So no, another way to do it is through just vanilla load balancer. So you can create a service of type load balancer, but this would only work with Kubernetes distributions that support load balancers, and those are typically your cloud hosting providers, right? You don't get load balancer if you do like a self-hosted kubeadm cluster, right, or Raspberry Pi cluster. If you mention that your services of type load balancer, Kubernetes just doesn't know what to do with that information. But if you do it on, let's say, DigitalOcean's Kubernetes cluster, or if you do that with uh, GCP or Azure or AWS, they will create a load balancer, which is like an external load balancer. In case of AWS, it would be an elastic load balancer. In case of GCP, it would be the whatever the Google Cloud's load balancer solution is. And that external solution, that external load balancer would then forward all the traffic within the kubectl stuff, right? So there is a bit of a proprietary component to it. I don't feel really good about that. And also it creates like a single point of failure, right? So instead of having a particular node failing, you now rely on the load balancer being available all the time, right? If the load balancer goes down, doesn't matter how good your Kubernetes cluster is architected, right? It would not get traffic. Your app would go offline. So, I really don't like the idea of that. I mean, I feel like Kubernetes has kind of missed the mark on that. But it's not fair to, put it on Kubernetes' doorstep anyways, right? Like it's the way DNS works. It's the way uh, we set things up, right, in networking itself, which kind of causes this issue. However, load balancers are surprisingly robust, and cloud providers do put in a lot of effort to make them highly available and all of that. So the chances of a load balancer going down is much lower than a vanilla, node going down. So there is that. So that was a bit of a ramble or digression, but yeah, so that is another way of exposing a service, right? Load balancers. However, you don't want to do load balancers all the way through, right? Let's say you have 5 different services, right? You have a service for analytics, you have a services for login, you have a service for web view, the home view, what have you, right? And if you create like a load balancer for each of them, that would cost you, right? Because each service would spin up its own load balancer instance, and it's probably like a lot of wasted resource because you can use one load balancer for everything. And that brings us to Ingress. What Ingress does is it takes the load balancer and it leverages it as a, okay, like the experts are going to butcher me for putting it in this way. It's like a reverse proxy server, but for the entire Kubernetes stack, right? So you can write your app in a microservice architecture, right? Like slash login slash can be a container of its own. Slash endpoint one, like we showed, right, could be a container of its own. And you can create a lot of containers within your Kubernetes cluster, and then you can set up an ingress rule for each of those servers, right? And your ingress controller would be like nginx. It would do all the reverse proxying, right? It would map all the paths. It will become much clearer as I show you the demonstration, but that is the idea behind Ingress. In fact, we will be using nginx as the Ingress controller in this case. So nginx, not nginx, but like Ingress controller is like a web server. In fact, if you look at the documentation, uh, Ingress is strictly HTTP, right? So all it does is HTTP and HTTPS routing. And you can see like this is the model that I was just describing. Um, yeah, you have a routing rule, and the routing rule can go to service 1, service 2, service 3, and you have a single ingress managed load balancer, and it just does everything. But what does it look like in practice, right? So we have kubectl get service. Just to go back to where we are, we have our service. It doesn't have an external IP. Let's first deploy an ingress controller because that is needed for you to start operating with it. And the question is, how do you deploy an ingress controller? Again, this is where I have some problems with the way Kubernetes likes to do things. The project, not the actual technology, like folks who are responsible for maintaining Kubernetes, I have a problem with that, with the approach that they have. So let's do Kubernetes Ingress controller. Wait a second. It's nginx ingress controller deployment. So the way they do it is like they have all these different instructions, and you just go and copy paste a kube or like a kubectl command or a helm command. Right? Helm, if you don't know, is like a package manager for Kubernetes, but you can just as easily just go to DigitalOcean and copy paste DigitalOcean specific command here. So you go here, you paste this random deploy.yaml, and if you really want to look at it, I mean we can, but you see that like this is like hundreds, if not thousands of lines of random YAML. It feels really weird to, like do things this way. But I mean, this is the state of technology right now. I'm not happy with it, but well, what can we do? Let me know in the comments if you have a proper solution for this. Like, if we can create an ingress controller in a cleaner way. I think, like, I mean, criticisms aside, right? Like, this thing does a lot of work as well, right? So it does hide away a lot of complexity in a single command. There is something to be said about that. Yeah, so we have our ingress controller deployed, or at least we should have it deployed. We can check that by get pods. We'll have to change the namespace to cube. I think it's cube ingress. I'm not sure. Nginx ingress. It creates a different like namespace for itself. Let's just do all namespaces and we'll find it out. Yeah, ingress nginx. So you can see it created. Um, yeah, it's creating a container. This is our ingress controller. The first two are just routine jobs to like bootstrap the controller. They just they run once and then they exit. Yep. So the ingress controller is deployed, as you can see. Nginx ingress nginx controller 1 out of 1 running. Good. So we have that going on for us. Now, uh, if you go to your Kubernetes dashboard or your cloud provider's dashboard and you check the networking tab, you will see that they're actually spinning up a load balancer for you. So in my case, DigitalOcean is actually spinning up a physical load balancer here. I mean, not physical, but you get the idea. Let's reload to see how much progress is left. It will take some time, so I'll just cut it here and come back when the load balancer is deployed. So the load balancer is up and running. It has a public IP address, and what I have done is went to my Cloudflare because you need a fully qualified domain name for this. I have ironv.com registered, so I just forwarded www.ironv.com to the same IP address. I turned off proxy and stuff because don't want things to be messed up by that. And the load balancer is up and running and the ingress controller is up and running. How do I know that? Well, let's see. Yeah. So if I go to www.ironv.com, I see this nginx page indicating that there is an nginx server somewhere responding to this. And that's our ingress controller at work here. Of course, the ingress is not set up, so it's returning a 404 because I haven't set up any, response for this route, right, which is like the slash route. I'm not going to anyways. What I'm going to set up instead is a route for, uh, let me just show you. I'll set up this ingress route, which just takes the host www.ironv.com and slash endpoint, and it forwards this whole um, like whatever traffic is trying to reach this endpoint to my deployment. I think I should change the service name there. So let's do that really quickly. I called my service my service, creative name, but yeah, what you want to do. And the port number is 80 because I configured my app to listen on port 80. Can be any other arbitrary port internally, but let's keep things simple here. I mean, externally, you'll always be hitting port 80 and 443. That's the thing with Ingress. Ingress only works for port 443 and 80, and it works only for HTTP traffic or HTTPS traffic. Um, that's that. Let's do a kubectl create f ingress. So I'm creating an ingress object, and if everything was done correctly, I can go to slash endpoint one and have a bit defender error. But that's because it's trying to reach HTTPS and I haven't, like, there are no there are no cert port certificates here. There are no like proper verified SSL certificates here, like you would get from Let's Encrypt, let's say. So I will have to go and settle for HTTP traffic, and you can see it returns hello world. And that's that. Like, I mean, you can even try it in curl www.endpoint1 and it returns hello world. You need a fully qualified domain name for this, although, I mean, in my testing, I wasn't able to make it work with a non-verified domain name or an IP address or something like that. Although there are ways to do it locally if you're using Docker Desktop, let's say on Windows or Mac, they have different sets of instructions to, get your ingress and ingress controller up and running on a single node cluster over there. Same with Minikube, but yeah, this is how you would do it, like let's say with a real world example. Eh, so that's that. I hope you found this useful and I'll be signing off. Have a nice day.